Hi, this is Taylor Garrison, and I'm going to be doing proof number 4. We are given a parallelogram ABCD. This parallelogram is bisected by line segment AC and line segment BD. We are trying to prove that triangle ABC is congruent to triangle CDA. Based on the properties of a parallelogram, we know that angle A is congruent to angle C because the opposite angles of a parallelogram are congruent. From this, we also know that angle B is congruent with angle D. We also know that line segment AB is congruent to line segment DC because the opposite sides of a parallelogram are congruent. From this, we also know that line segment AD is congruent with line segment BC. Now I'm going to mark the given information. Angle A is congruent with angle C. Angle B is congruent with angle D. And line segment AD is congruent with line segment BC. And line segment AB is congruent with line segment DC. Now I'm going to redraw the diagram so it'll be easier to see. So we know that angle A is congruent to angle A because they are the same angle. We also know that angle C is congruent with angle C because it's also the same angle. And we know that angle B is congruent with angle D. We also know that line segment AC is congruent to line segment AC because they are the same line segment. So now we can finally prove that triangle ABC is congruent to triangle CDA, or as I have drawn here, ADC, which is the same thing except flipped around. So we can prove that triangle ABC is congruent to triangle CDA from the congruence conjecture, angle, side, angle. So as you can see, we have an angle, we have a side, then we have another angle, we have an angle, and we have a side, then we have an angle. So we can now prove that triangle ABC is congruent to triangle CDA by the congruence conjecture, angle, side, angle.